Okay, so let's go up here. I'll start in C and I'll put, let's see, this is the standard 345s. This is the standard 250s. And we have the industrial 345s and the industrial 250s. I'm also going to put up here a total. Okay, that's a decision variable. If we do it with a summation variable, it has to be treated just like all the other decision variables. I'm going to throw 1, 1, 1 in there just to seed this thing. Okay. And I'm going to put my profit here. I think this was 400 and this was 500 and this was 560 if I recall, and this was 700. And because it's not there, I assume it to be 0. I could put in the 0 if I want. I don't know why I put a 1 there. Or I don't need to. But when I put in my sum product function, I need it to contain the whole range. And when I say that, I mean I need to include the summation variable. So C2 through G2, comma C4 through G4. And I want to make these static. Okay, so if we make one of each, we make $2,160. Skip a line, subject to, let's put in my zinc, and my zinc is 25, 16, 46, and 34, 0. Copy my formula down, whoops. And it has to be greater than or equal, less than or equal to 2,500. Iron coefficients are 50, 28, 30, and 12. And that has to be less than or equal to 2,800. Did I get my coefficients right? Correct me if I screwed something up. Okay. And then, before I enter in solver, I'm just going to define my summation variable. And the coefficients for this guy are 1, 1, 1, 1, negative 1. And that has to equal to 0. If I put an equal, sometimes Excel thinks I'm entering a formula. This time it didn't, but if it ever does, just hit the single quote and then the equal sign, and it'll accept it as a text. If you ever go into a cell and hit equal, and Excel assumes you're entering a formula, it doesn't let you do anything, use the single quote, and that'll say, this is text. See, like I just did there. So, single quote equal, and I'll say, all right, just text. And I want to say equal to 0. All right, I'm not going to put in my variables down there yet because I just want to make sure, and a lot of times I like to do this through a series of like progressive elaboration, right? Like build it, see if it works, then add on the next constraint, and then on the next level. Because when you do this all at once and it breaks, you don't know where the problem is, right? If you do it, you layer it on top of each other, you can say, well, it worked a second ago, so it must be the new thing I added, right? So It's a good debugging mechanism. So I'm going to go up to data. I'm going to invoke solver. And we're going to say my objective function, the one thing that I'm maximizing is H4 in my case. That's where the profit lives. I'm going to tell it about all my decision variables, including that summation variable, including the G, right? All those things are decision variables. So I have to include that. Subject to the constraint. Okay, well, I'm going to add these two together. Add the fact that H6 through H7 has to be less than or equal to J6 through J7. And finally, H8 has to be equal to 0, or J8. Okay, so maximizing my profit, which lives in H4, changing all these variable cells. H6 through H7 is less than or equal to J6 through J7. That's my zinc and iron, respectively. And H8 has to equal to J8. I'm defining it at that point. Let's change that to simplex LP. Let's click solve. Let's see what we get. All right, so at this point, we have a solution. Now, I didn't add all my other constraints, but we have a solution, okay? And it says if this was the only thing I was dealing with, we'd make 85.78 250s standard and 33.15 250s industrial, and we'd have 118 units roughly, and we'd make $66,000. Now, adding those on, okay, adding on the new constraints. I think one of the constraints said, hey, industrial models have to account for at least 50% of production. Do they right now? In this model, do they? No. Okay, so when I add on that constraint, I know it's going to change my solution. And because it's going to be binding, what do I know about my solution? Is it going to go up or is it going to go down? Is my profit going to go up or is it going to go down when I add in this next constraint? If I add more constraints to something, is it going to be easier to maximize or harder? It's going to be harder, and it's going to go down. Let's try it. So at least 50% have to be in industrial models. So I'll just say 50% IND. That'll be my abbreviation for this constraint. And let's see. X1, X3 plus X4 minus 0.5 X5. Okay, remember I'm just focusing on the coefficients. Copy this deal down. Has to be greater than or equal to 0. So let's add in this constraint and let's see it in action. So I'm going to click solver again. Everything's still there. Add in, and we're going to say, hey, this, which we're violating currently, needs to be greater than or equal to 0. I click solve. Solver finds me a solution. Now it says make 50 250s, standard 250s, 50 industrial 250s, make 100 units, and my profit did go where? It went down because I added a binding constraint. Think about that feasible region. I'm making it smaller, making less things feasible. I'm not allowing it to push out profit further. But it's adhering to all my constraints. Agreed? Agreed. It also said that neither the 250s nor the 345 should account for more than 75% of production. Well, let's add in the 345. So 75% 345s. So that's my X1, X2, I don't need to put anything here, minus 0.75. Copy this deal down again. Has to be less than or equal to 0. Now when I tell it about this constraint, is it going to change my solution? I want you to think about that. Is it going to change my solution when I add this constraint, this particular constraint? Yes or no? Well, the question you have to ask yourself, am I violating it right now? Am I violating it right now? I'm not. So is it going to be binding? No. So is it going to change my solution? It's not. Let's see. Solver, add this constraint. We're saying that H10 has to be less than or equal to J10. Solve it again. You see my solution is the same. However, when I do 75% of the 250s, let's see, that is, oh, I did the wrong one, didn't I? It should be here and here. Okay. 75% of the 250s, that's, yeah, that's right. It's x2 and x4 minus 0.75 x5 has to be less than or equal to 0. Now, how about this constraint? Adding this, is it going to change my final solution? Is it? It is. And is it going to make my solution better or worse? Because it's binding, is it going to make my solution better or worse? It's going to make it worse. If I click solve, click add, this H11 has to be less than or equal to J11. I click solve. We find a solution. Let's keep the sensitivity report this time. And here it says you need to make 23 roughly standard 345s, 23 roughly standard 250s, no industrial 345s, and 46 roughly industrial 250s for a total production of roughly 92 units, and we make about, looks like about $52,000. And I think our first blush at this was like 66,000, right? So the more binding constraints we added, the more this deal went down. Okay, that makes sense. So, did we hear to all our constraints? Well, let's see. Okay. We're using 2,500 pounds of zinc. We have 2,500 pounds of zinc. So what do we know about the zinc constraint? Binding or not binding? Binding, right? How about iron? How do you say iron? I always say it like a Western Pennsylvania person, I think. Iron. We have 2,800 pounds, and we only use 2,340, so is it binding? No. Definition always is going to be binding. How about this? We said we need to make at least 50% industrial, and lo and behold, we're making exactly 50%. Is that binding? It is. Okay? Because if it's solved with equality, like you see here, 2,500, 2,500, 0, 0, that thing is binding. How about this one? 75% 345s? No. But this one, 75% of 250s? Well, it is. Because we're making exactly 75% of 250s. We could probably make, if we relax that constraint, we could probably make more 250s and make more money, but we didn't. So now going back to what we talked about last week. So I know what's holding me back. As a good manager, I want to also look at this solution and do like post hoc analysis. So let's go over the sensitivity report. And let me just make up some questions here. Okay, I made, looks like I made 23 standard 345s. The profit coefficient for 345s is $400. If I started to be able to make 345s for $500. Make a profit of $500 for a standard 345. Would it change my solution? It would change my profit, but would it change my mix? It would not. Why not, Dylan?
Because your allowable increase is 316, 500 is within that range.
So this is telling us this is the right mix. Even if we go down to the allowable decrease is 100 roughly, even if anywhere between $300 and 400 plus, anywhere between $300 and $716, this is the right mix to make. That's good to know, right? Because if these were estimates, this was someone pulling it out of the air, hey, this is a good solution no matter where we're at, right? That's a good thing to know. We see industrial 345s. We're not making any. So what does industrial 345s have that none of the other ones have? It has a reduced cost. What is that reduced cost telling me? $103.30 roughly. What's it telling me? Two things it tells me. What's it telling me? If I made one, if I said to hell with it, I want to take some of my production capacity and make an industrial 345, I can do that, but what happens to my profit? It would decrease by this amount. Alternatively, it says, for it to be profitable for me to start making these things, I have to reduce my cost by $103 per unit, or in effect, my profit has to be at least $103 higher than this value. Does that make sense? Those are the two things that's telling me. Let's go down here and take a look at my shadow prices, my constraints. We notice zinc, we used all 2,500 pounds we had. The shadow price for zinc is $21.10. What is that saying to me? Okay. If I get an extra ton, or I don't know what this pound of zinc, right? My profit will increase by $21.10. If I get 2 extra pounds, my profit will go up by twice that, or $42.20. If I get 3, it'll go up by 3 times that, or what is that, $63.30. Okay. I can't do that forever and ever and ever. Just keep adding more zinc and getting more money. It tells me via these two numbers what that range is. I can keep going up an extra pound, gives me an extra $21, up to an extra 492 items. That's called the range of feasibility. Now Thurston said that should be what we'd be willing to pay for an extra pound of zinc, right? Or ton, or whatever we're talking about here. But it actually, if zinc is included in the profit coefficients, it's not the amount we're willing to pay, it's the amount we're willing to pay over what? Over what we normally pay. It's the premium we should be willing to pay over what we normally pay. If we normally pay, I don't know, $50 a ton, we should be willing to pay up to $71.10 per ton. Because that $50 cost is already factored in to this. It's already being accounted for. So the $21 doesn't represent what we should pay, it represents the premium above what we normally pay. It's called a premium, okay, because it's an included cost. Okay, anything else interesting on that? All right, let's try to do this the other way, without the definition constraint, all right? So I'm going to bastardize this to do so. Well, maybe I'll save this. I'll make a copy of it. So I have a good version and a bastardized version. So, first off, we know we no longer need column G. Okay, we're not going to include column G. But what we do know is that we need some cell to represent the total. And we're going to use our friend sum. And and we're going to say sum C2 through F2. And I'm going to have to change some of my things here. Let's look. I think that's all I really have to change, but if I go to solver, I'm going to have to change some things. So solver says I am maximizing G4, that's all good, by changing cells C2 to the F2, so only those four, that's good. G6, G7, less than or equal to I6, I7, that's good. I don't need this 8, right? I don't need this anymore, because I don't need to define this, so I'm just going to delete that guy. What's this? 9, 10, 11. Let's get rid of those and build them back up. Right, easier to start from scratch. Okay, so I have these two for my zinc and iron. Now I need to add this. Let's add the 50% industrial. So I'm going to say add. The total in industrial is G9. That has to be greater than or equal to our sum, which is H9, or H2, I'm sorry, times what? It has to be, 50% has to be in industrial, so times 0.5. Add the 345 total, which is in G10, has to be less than or equal to 75% of total production, which is in H2, so H2 times 0.75. Add, and the 250 production, which is in G11, has to be less than or equal to H2 times 75%. G4, maximizing, C2, F2 are my decision variables. G10 has to be less than or equal to 75% of the total. G11 has to be less than or equal to 75% of the total. My zinc and iron here are good. And we have to make at least 50% of industrial models. I click solve. Solver found a solution. And it found me the exact same solution. And just to make sure it did, let's reset this. Let's go to ones here and just try it again, just to make sure it worked, and arrived at the exact same solution. So I don't know which one might be easier for you, but whatever you think is easier for you, that's the one I would like you to do. Okay, I want you to understand it both ways, but I want you to think about what works for you and what doesn't work for you. It's your call on that one. Okay, but that's two ways to do it, with the sum function and with defining the variable and using the variable. So questions on that? Okay, what other problems from the homework assignment would you guys like to take a look at? Was there one in particular, or was there many in particular? Was there... Yeah, Adam, go ahead.
18.
What number?
18.
Okay, let's take a look at 18. This is on page 174.
portfolio analysis. Yeah, this one didn't require summation variable, and there's a reason why it didn't. So Sarah Williams has $100,000 to allocate to the investments listed in the following table. Bill Wallace, her investment counselor, has prepared the following estimates for the potential annual return. So we have 4 investments, each has an expected return, a minimum return, and a maximum return. Sarah wishes to invest her money in such a way as to maximize her expected annual return based on Bill Wallace's projections with the following restrictions. As soon as I see that word restrictions, I'm thinking what? Constraints. Very good. So if we take a look at this, I'll kind of do this quickly on the board. But what are we deciding? What are we deciding for this person, this client of ours, as we counsel them in their investment life?
How much money do you invest each?
Okay, very good. So whatever those are, we'll call them X1 through X4, right? I don't know what they were, gold and all kind of things, but we have X1 through X4. How much to invest in each of those 4 investments? Okay. What's she trying to maximize or minimize here? What is Sarah trying to maximize or minimize? Sarah wishes to invest her money in such a way as to maximize her expected annual return based on Bill's projections. So what that would look like is maximize, and the expected return column is, let's see, 15% X1 plus 9% X2 plus 7% X3 plus 8% X4. Make sense? Yes, no? Okay. Now, for this one, we really don't need to use a summation variable. Why? What part of this, I could if I wanted to, but I don't have to. What's that last bullet point say? All $100,000 is to be invested. So, guess what? I know the total. What's the total going to be? 100,000. So, a constraint is subject to X1 plus X2 plus X3 plus X4 equals 100,000. Okay. So now all these become easier, truthfully. At most, 50,000 of our investment should be in stocks. So the stocks, I guess, are 1 and 2. So at most, that means we're saying X1 plus X2 has to be less than or equal to 50K. At least 60,000 of our investment should have the potential of earning a 9% or greater annual return. What has the potential of earning 9% or greater? Well, 1% can earn 100%, that'd be nice. Cascade Telephone can earn 12%, and the money market can earn 9%. So X1 plus X2 plus X3 has to be greater than or equal to 60K. Yes? At least 70,000 should be liquid during the year. This implies that at most 30,000 could be in 2-year treasury bonds. So that one becomes easy. That just says don't put more than 30K in X4. And the maximum overall annual return should be at least 4%. The minimum overall annual return. So the minimum column is negative 0.5 X1 plus 3% 3, 6, and 8.
So plus 0.03 x2 plus 0.06 x3 plus 0.08 x4 has to be greater than or equal to, well, what's 4% of 100,000? 4,000. So all I have to do is throw my 4K over here, 4,000. If I didn't know, the minimum return says the minimum overall annual return should be at least 4%. The minimum column, which is in the middle, if you look at that table, says Bonanza Gold, the minimum it can do is negative 50%, so that's negative 0.5. It says Cascade Telephone, that's X2, is minimum it can do is 3%. The next one's 6%, the next one 8%. You see those? And now, if it says 4%, if I didn't know I was investing all $100,000, I would have to use a summation variable, right? But in this case, I don't, Adam, because I know I'm forcing in all 100K up here, which my board's a little wet, so I'm sorry I can't see that. But I'm forcing in all 100K up here, right? Now, if I didn't know what I was going to invest, you're darn right, I'd need to use a summation variable here, right? I would. I'd have to say, has to be greater than or equal to 4% of the total, and then I'd have to bring over minus 0.04x5. You know, I mean, I'd have to use it. But this one, I don't know why they, in the summation variable chapter, I don't know why they didn't make it that way. Maybe they didn't know what they were doing, but anyway, that help?
Yeah, because I just didn't get why don't you need the
Summation variable.
total?
Yeah. What else in this chapter section? All right, so I'd like to take a break around 7, but so we have like 15 minutes till 7. So what I want to do with that 15 minutes is let's talk about, and then we'll start new material after break. Let's talk about the midterm take-home, okay? So I want to show you where that's at, what I'm looking for, all those things. We can answer all those questions. So if we go to Blackboard, and you go to the navigation, it says take-home exams. Do you guys find that? And under take-home exams, go to student view here. There's a folder that says midterm exam. Click on that. And then there's a document that I uploaded today. It says midterm take-home due February 24th, 2015. So it's due the same day we have our in-class. So that's 2 weeks from today. Okay, so you have roughly 14 days to do this. And it consists of 4 problems. Okay, that's it. And in each of these problems, say they're worth 10 points each, so it's 40 points, all right? Here's what I'm looking for you to do in this case. Please solve each problem fully and answer any follow-up questions in narrative. Okay, circle all answers. For the linear program models done in Excel Solver, I would not only like you to print the spreadsheet with the end results, but I also want to see the decision variables, objective function, and constraints that you modeled using Excel Solver. This portion can be handwritten. So I'd kind of like to see this part and then the corresponding Excel work, right? And the reason for that is if your Excel's wrong, right? It's 10 points and I don't know what the hell you did wrong, it's hard for me to give you partial credit. But if I can look at what you did, I can oh, here's what they did. They got an 8 out of 10. You know what I mean? I can find the mistake. If you just have an answer and it's wrong, it's kind of like binary. It's either a 0 or 10. So I'd like to see, the handwritten portion and the Excel work. I don't care about the format. Don't waste your binders and your glossy papers on me or paper clips or anything like that. I don't care how you get it to me, what format it looks like in. I'm concerned about the content, right? So I want to hand it in, like in paper form, okay? I've tried having people submit it, but that became a mess. So I want you to hand it in, stapled together, whatever, bound together somehow, but it doesn't have to be a thing of beauty. It doesn't have to be anything, right? It can be notebook paper for the first part, stapled to your Excel spreadsheets, okay? So
That's what I'm looking for, okay? So here's what I'd like you to do for, any questions on that part first? Okay, here's what I'd like you to do. The first one is a production mix, okay? It's a made up production mix. We're making 2 tennis rackets. This one should be pretty easy for you, right? It should be pretty easy. I want to know how many rackets of each type should this manufacturer make over the next 2 weeks to maximize total profit. You've seen that before. Assume that because of the unique nature of their products, CSD can sell as many racks as they produce. And then I want you to answer these questions. What is the optimal profit? You know, once we solve it, how much do we make? What constraints are binding? You know, what's holding us back? Remember, we talked about that tonight. Interpret at least one shadow price. So what I'm looking for is you to go to the sensitivity report and find something that has a shadow price and write a sentence or two explaining to me what it means. Remember when the Mary's Bakery one, I said, hey, for every egg I get an additional 8 cents to my profit, up to an extra 500 eggs. You know, that's all I'm looking for there. It doesn't have to be, you know, just in English, you know, in plain layman's terms. And what is the range of optimality for both standard and oversized rackets? All right. Okay. The next one is in our text, and it's page 180 of your textbook. So I'm having trouble projecting things, so I'll just read it. It's number 36, and I want you to do A and B only, okay? There's a part C that you don't have to do, so do A and B only. This is advertising. We have a budget of funds. We have options to advertise in TV, radio, or newspaper. We need to decide how best to advertise to. Looks like in one case we want to reach the maximum total audience. In the other case, we want to wish to reach an audience of 30 million at minimum total cost. So we're looking at the same situation a little bit differently. In one, we're saying I want to spend. I don't care what I spend. I want to maximize my reach. The other one say I want to spend this much, and in doing so, I want to maximize my reach. So that's number 2 is number 36 on page 180 of your text. Okay. Number 3 is a Miko made up one, and to tell you the truth, we were going to go over this one tonight. Not this one, but this form of problem. This is an integer constraint problem, and we haven't done those yet. But you'll see tonight, it's not very much different than what we've done. It's a staffing model. Miko ABC Health Group is setting up a new healthcare center in a rural area and is trying to decide how many nurse practitioners, physicians, and physician assistants they can hire. Each has a weekly salary, so that's a budget I have. Each can serve so many patients. You see here that I want at least 40% of my staff to be physicians. What do you think I'm going to need for that? 40% of my staff to be physicians, but I don't know what my total staff is. I'm going to need a summation variable or a sum. And as well, neither nurse practitioners nor the PAs should account for more than 40% of the total staff. That's 2 separate constraints, right? I'm going to have a nurse practitioners has to be less than 40%, and a PAs has to be less than 40%. Okay? So that's a staffing model. That's an integer one. So that's number 3. And number 4 is a production mix, but it's a little bit different than the first one. Okay, it's a little bit different way of thinking. It's a blending model, if you will. We are making wine coolers, and to do so, we are blending together certain products: white wine, rosé wine, and fruit juice. Okay, and we want to determine the blend of the 3 ingredients that will maximize the total profit. Okay, but we have to have some things in there. You see, like we have mix constraints. It has to be at least 50%
fruit juice, or between 20 and 30% of this. So we want to maximize our total profit in doing so, but we want to make sure it has these, it meets our requirements for the taste that we've set for our fine product, right? So, formulate a linear program, solve it to determine the number of gallons of each ingredient to purchase and the total profit so that they will realize from this brand. Interpret at least one of the shadow price. And here's one where you have to look at if we were able to acquire additional white wine from an outside vendor for $3 per gallon, should we make the purchase? And that is, white wine is an included cost, so you need to figure out, hey, you know, is this, how much should we be willing to pay above the normal rate? What's the premium we should be willing to pay? Okay, so I give it to you 2 weeks in advance for this reason. If you work on it this week and you come with questions next week, I'll help you. I'll answer questions for the whole damn class. Okay, so if you have a question, like I don't understand this, you know, maybe we'll set it up for you. Okay, so you have 2 weeks to do this, so don't wait until February 23rd to start it. Okay, start it now. It's good practice for the actual exam. And like I said, you know, if you're struggling with one, bring it in. We'll take a look at it and we'll think about it differently. All right. Any questions on that? Always questions about the exam. No questions?
So is that like what the in-class exam will be like? Except just setting it up?
Yeah, the in-class exam, kind of. I mean, I'd say the in-class exam is actually probably a little bit easier. Yeah, I mean, the problems themselves are probably a little bit more straightforward, you know, probably a little bit. I'll talk about that next week. We'll go over next week, you know, I'll talk about the types of questions that'll be on the in-class, the types of problems, but you won't have to solve it on the in-class. You know, once again, in-class, open book, open notes, open laptop, you know, bring whatever you like to class that evening. You have the entire class period. We're not having class before it or after it. Once you're done, you can go. There's a multiple choice portion, which, you know, kind of tests the concepts and your understanding of the concepts, things like sensitivity report. And then there's a problem portion and it gives you like a little word problem and asks you to set it up kind of like that. Okay, identify those three things. Okay. All right, let's take a break, and then we'll come back and hit integer and binary. So it's like 3 till 7, so I'll come back like 7:12-ish.